Tata Consulting Engineers Limited
Put
for over
this
16 years. He has been playing pivotal leadership
I
roles
left in 2005.
excellence, asset
2005.
integrity,
April 2000,
project
March was
management,
the
and
last
ethics.
month.
He holds
April
a
onwards, I was in Orissa
industrial
Spawn.
engineering
From
and
Orissa Spawn, I
BE
moved to
in chemical engineering
Tata
and
Group.
is currently pursuing his PhD.
More than 21.
His professional credentials
21
include
years.
Chartered Engineer, Learn Six Sigma Green Belt, EVEF Assessor, ISO 9001 Auditor, and Data Champion. He has served as an external EVEF assessor for multiple Tata Group companies and has been a team leader for EVEF assessments since 2022. He is also recognized as a subject matter expert in deep dive assessments focusing on operational excellence and customer centricity. Known for his structured, values-driven leadership aligned with the Tata ethos, he consistently emphasizes sustainable excellence, leadership capability building, and long-term stakeholder value. His contributions have been recognized through prestigious accolades, including the Value Award for Customer Centricity at Tata Consulting Engineers and recognition as Star Team Leader for the TPEM Assessment 2024 cycle. On behalf of organizing committee Solve 2026, I warmly invite him to deliver the keynote address. Sir, kindly have the floor.
Do I have to stand here or I can stand here? Thank you. My voice is clear? And all of us are freshened after a cup of tea? Or no? और एक बार चाय हो जाए? All right. So, before I came here, on the way, I used Microsoft Copilot. Anybody understands Copilot? Or all of us are aware of ChatGPT? Okay, perfect. So, just to understand what Vignan is doing basically in terms of sustainable engineering, what type of research they have done and all that. That was actually done. I added that slide while traveling here. Just for the purpose of giving a context, let me show you what I got from Copilot. Okay, if I miss something, blame it on Copilot. Okay, so I could see that there are around 40 peer-reviewed publications. There are 25 plus citations, and if you see, it talks about Solve 2026 International Conference, and if you look at where are this citation academic research has happened, it has gone to different places like IITs and IITs and all that. Okay, and how you are actually positioning yourself, because vision is very important. Okay, how this institute is actually positioning itself in terms of sustainability has been mentioned here. You are looking into applied sustainability. I have gone through certain articles, just glance through that. Typically in civil engineering and mechanical engineering is the predominant focus area for you. So that's pretty good. And then if I move on to what I really love to show you is, thank you for this opportunity. Typically at the end of the presentation, probably I might forget. So I wanted to start with a thank you slide. Thank you so much for calling me. Berhampur, I am not, I'm very close to Berhampur in the sense that I spent almost 15 years of my childhood till my class 12th here in Berhampur. And I've been associated with Professor Prasad, Ishwar Rao Garu, and many other of your colleagues. So it is lovely to meet them after maybe 21 years, right? So thank you so much for this opportunity. I am not a research person as of now. I have left engineering long time back. So probably what I'm going to tell you is basically common sense and what I have learned over the years in my 33 years of journey as a engineer, then into project management and so many other things which Dr. Behera kindly informed, which was quite exaggerating. I am not that, but I was very happy when you actually said that. But anyway, so if I move on to basically my company, from where I get my money, रोजी रोटी कहाँ से आता है? So I need to speak about this company as well. I got 2 slides on this. What I would like to emphasize is Tata Consulting Engineers is the India's largest pure play consulting engineers. So we got around 9,000 resource pool, technical resource pool, who typically develop many iconic projects. If you talk about iconic projects, high-speed rail, Mumbai Ahmedabad is being done by us. If you talk about Ajodhya Ram Mandir, it has been designed by us. Parliament House has been designed by us. If you talk about Sardar Patel's statue, that has been designed by us, and so on. So there are so many iconic projects, including your Chandrayaan. Many of the Chandrayaan's design was actually done by us. So I am very fortunate to work here, and I got basically a sort of a guidance and sort of you can say tutelage to really hone my skill in two areas, which I am going to talk about. One is something called as value engineering. Anybody who is aware of value engineering? Most of the students here, have you heard about value engineering? No? No? What basically is value to you? When you say value, what does it mean? What is value? Anybody can attempt? Let's make it more interactive, gentlemen and ladies. Okay? Value and cost, is it same or different? I'll give you an example. You go to a roadside tea stall, you ask for a cup of tea, he gives you a cup of tea, you liked it. You say, chai acha hai, bahut badhiya hai, right? You pay me how much? 10 rupees? Imagine you go to Taj, Hotel Taj, there you are asked for a cup of tea. The tea quality will be same, right? But there is something different which is actually costing you more. You may have to pay something around 400 rupees or 500 rupees in Taj. What is the difference there?
Psychological satisfaction.
Sorry?
Psychological satisfaction.
Psychological? The way the things have been delivered to the customer is value. I'll go for one thing, something else. Engineering. All of us are engineering students. Some of you may join my company as a consulting engineer. The moment you design something, there is something called as a basic need. Understood? Light. What is the basic need for a light? Lit, louder. Electricity. Illumination, right? Now I go to a consultant, architect. I say that I need you to design a light. He will prepare a beautiful pillar, designed, colorful, with a light. What will be the cost of that light? Give an estimate, please. 5 lakh, 10 lakh? Yes or no? But if I go to a shop, ask, भैया मुझे घर में light लगाना है. What do I get? Electric bulb. They serve the same purpose or not? So the basic requirement can be solved by a bulb. The same thing can also be served as a elaborate design, colorful design, and so on, right? So that is where value engineering comes. Value engineering talks about how do you really disintegrate the entire requirement plus something called as aesthetic needs. As an example, if you go to Taj, the aesthetic need is very high. Okay? When you go to Taj, you expect somebody to be uniformed. He will bring you the tea in a really decorated tray, and the coffee will have a smiling face, right? When you go to a shop, chai wala, you don't look for it, that, what do you call it, smiling face. Am I right or wrong? So that is where the customer requirement will define. And why it is important when you talk about sustainability. And if you talk about my topic. If you talk about my topic today, I am going to discuss something about life cycle assessment. I think some of you are quite familiar with the subject. Typically, what we are trying to say is there anything which I can do to look from a sustainable engineering view? And I am very fortunate to say that TC is in the forefront for sustainability and energy transition. These are the different areas I am doing, and this is very important. As sustainability shifts from intent to accountability, you can have a good intent that I want to save the planet, right? I want to reduce my carbon consumption. But when I travel here, I do not use an electric vehicle, I use a diesel car. That is where it is still intent. I don't want to really increase the carbon footprint, but I'm being forced to use a diesel car. In fact, I came in a diesel car today, right? Life cycle assessment becomes the engineer's most powerful decision tool. And in all our engineering, not only ours, any consulting engineer across the globe, the buzzword is look from sustainability and life cycle assessment. So I've got few slides to explain my thoughts, and I know all of you are more knowledgeable than me, so I expect there are no further questions at the end of the presentation, right? Okay, so what I'm going to discuss today is, I've got few slides to set the context. Then I am going to discuss about life cycle assessment from sustainability intent for engineering decisions, and then I will also show you certain examples of how sustainability has been engineered, and then we'll also discuss how that thing can be taken forward. Okay, all of you are with us, with me today? Happy to go further, or abhi band kar dete hain? Okay, perfect. So let's start this. Look at this diagram. Anybody who has seen the diagram before? This is from biodiversity consulting. There are 3 graphs. All of us are very comfortable with graphs, right? Engineering students are very comfortable with graphs. Wherever you see, there are lot many graphs. Hai na? Tell me if I am wrong. So there is one graph which is in black in color. Then there is something which is in amber, and there is something in green. What is the difference between this? If I do not do anything, this is how the nature is going to get degraded and it will become extinct. If you look at here, it is actually in the move path towards extinction, right? And if I do sustainable conservation efforts, I am likely to go this path, which is in amber color. But if I go for more sustained effort in terms of looking for sustainable production and sustainable consumption, I am likely to be positive, nature positive by somewhere around 2070. The entire world is now looking for this. How do I really go into this? And intent is there, but when you talk about implementing, things are different. Because when you become an engineer tomorrow, and when you go for a job as a consulting engineer, the customer's requirement is very simple. All of you have been customer in your life, right? When you go to a shop or any place, what is your requirement? You get the best thing, right? At low price. Best thing at low price. The difference is basically your value. So customer is looking for a value, and when you want to design something for the customer, unless until you have that ability to convert your thoughts in terms of sustainable design, to convince him that this is going to give you more value, the customer is not going to agree, right? So that is where it is very, very important for the younger generation here to focus on this and try to cultivate, capture this in your, when you take it forward, okay? Now look at this. This has been quoted by World Economic Forum. Nature risk is the biggest financial risk. Why it is so? If I look for biodiversity loss, etc., why it is the biggest risk? What happens when, how is it related to finance first? The moment I am having certain climate change, etc., that is threatening half of global GDP. 50% of the global GDP depends on biodiversity and climate change. And that has got an impact of how much value? 10 to 25 trillion US dollars is the amount of unaccounted cost which is actually happening. And this is the risk, biggest risk for the world today. And what does the government do? At this moment, they are actually investing around 7 trillion US dollars per year in environmentally harmful activities. Can you give an example of harmful activity which is being done? Trump Sarkar, do you remember? Who is Trump? Donald Trump. What he has done? He said, भैया हमको नहीं चाहिए, I'll not go for any renewable energy and all that. I'll go back to my oil and gas. It's a pure economic sense. I have got oil and gas, which is cheaper for me. If I go for sustainable energy, renewable energy, it will cost me more. I don't want to do it on the behalf of world. Let me give a better time to my people so that I get re-elected. That is the thought which Trump has. And this 7 trillion, probably Trump's thoughts, Trump's ideas, being the biggest economy in the world, is also contributing here. Now look at this. Then what is the opportunity? Opportunities exist. If you go for a nature positive economy, it can unlock around 10.1 trillion by 2030. That is another 4 years only. You will be able to do it. And India is in the right path. Okay. And if you look at certain incentives being done by government, that is also in favor of going for this. The bottom line here is these risks which you have mentioned has to be driven by all engineers by going for life cycle based solutions. Okay. Now this slide is little complicated. Let me talk about India economy. If you look at India growth, India is in the right path to become the 3rd largest economy by 2028. And these are the key drivers which is actually happening. The key trends in the Indian economy is digital and AI. 2-3 years back, people were not speaking about AI, right? Now everything is digital AI. AI has moved in such a way that everybody is now trying to leverage use of AI, use of digital for better decision making, faster decision making, and so on. And many of my engineering calculations, automation, most of the repetitive work, I am trying to use AI for that. And that itself is adding a stress on the energy requirement. And if you look at the second aspect, urbanization, industrial build-up is basically something which is actually happening in India. Look at the roadways, transportation sector is growing. Everywhere you can see so many high-speed rails coming, metro projects are coming, and so on. So there is a big thrust of happening over here. And if you talk about the next aspect, which is very critical to India, is earlier China was actually controlling the global economy because the entire supply chain was based out of China. So countries are slowly trying to move out of that, and they look India as an opportunity. Plus, there are other locations as well, but India so far remains a favorable place for them. So that is where we see major investment happening for China plus one strategy with most of the developed countries. And then energy transition and renewal is the next major aspect which is actually happening. If you go through your newspaper today, you will find that 50% of investment which is happening is in terms of energy transition, in terms of energy only. You might have heard about Shanti Bill, nuclear going private. Government of India has recently decided to go for private participation in nuclear power generation. Are you aware of this or not? Why it is so? All of us have got thoughts saying that nuclear is a bad source for us, right? But nuclear is much more cleaner than that of the thermal power plant. And India is in a big way. India is looking at around 300 gigawatt of power generation from nuclear by 2030. And then look for circular economy. Okay. And if you look at the last 3, these are basically the focus area for us for life cycle thinking. Just to give the context, I have actually used the slide. I know it is a little clumsy. I am not going through the entire text, but just to give the gist of the things, India is moving, and there are 5 trends which is actually driving the Indian economy. These are the 5 trends, out of which, if you look at the third 3 trends which is actually below, which has been marked out specifically, are related to sustainability engineering. Now, how do you really use life cycle assessment as a tool for sustainability is the next thing which we are going to discuss. If you look from sustainability, there are 3 things which comes into picture: people, then you have got planet, and profit. Any organization, any businessman is here for making money, right? He is there for profit. So you cannot possibly say that you don't make profit. So tomorrow if I go for a design, I must also ensure that he makes money. Only thing is the way people look at profit has to be different, in the sense that instead of looking for a tangible benefit today, I must be able to project that how you are really going to get benefit when you go for a life cycle assessment. Simplest example is many of the industries earlier used to go for normal drives, but slowly people started replacing with variable frequency drives, VVFD drives. What was the purpose? The purpose is they are more energy efficient, and I've seen many of your research papers are based on energy efficiency only, right? So that is where the thought has shifted now from looking at the capital cost alone to something as a mix of capital and OPEX cost, and that is where your life cycle cost comes into picture. So what you are supposed to do when you look for sustainability is go for a balancing between these three: planet, people, and profit. So you have to look for economic growth, you have to look for environmental care, and you should also look for social well-being, focusing on people, planet, and profit. As simple as that. And how do you look into this? Your life cycle analysis, the concept is you look for how is your engineering or how is your design impacting the environment from raw material extraction to disposal. If you look at a product life cycle, what happens basically? You have got certain raw materials, okay? These raw materials are getting converted to a product, right? In this stage, there are so many factors which actually influence, and there are certain environmental impact happening, right? Yes or no? Look for your kitchen. All of you know how to cook, right? Is it the right question to ask or wrong question to ask? I don't know, but I assume that most of you know how to cook, right? And what do you normally do if you want to prepare a vegetables? You wash it, then chop it, then arey yaar, it is almost lunch time and I want you to focus on cooking. The ultimate objective is your raw materials were the vegetables, right? And you have done certain processing. And was there any waste created? Agreed? Then you prepared the vegetables, that is the product. In addition to product, was there any other additional waste created? Probably yes. Hota nahi hota hai. You boil potatoes. Aloo is the favorite stuff for most of the boys. है ना? Aloo and omelette. Am I right or wrong? You survive on aloo and boiled eggs, not boiled eggs, omelets, till you get married, right? All right. So if you talk about the life cycle assessment, it consists of four different stages. First of all, you have to define goals and scopes. Unless until you define your goals properly and scope properly, your vision will be very different. Okay. So you start with how do you really define this. So in terms of define goal and scope, you have to look for what are the different impact is going to happen at every stage of the product life cycle. Okay. If you go back to the cooking example, the amount of waste generated, what you normally do today? You throw it, right? Imagine a 5-star hotel, not 5-star hotel, a hotel which has got around, let us say 500 guests per day. How much amount of waste they are generating? Can you do something about it? Can it be done or not? It cannot be done. You can go for composting, right? You can go for biogas generation. There are so many opportunities available. The moment you look from your scope and goal, you will be able to identify what is the impact happening and how do I reduce it. Next aspect is you have to inventorize, you have to identify. Once you identify that, you should look for resource efficiency and waste reduction. The best method for impact reduction is to look for, can I reduce the consumption? The industry focus is there. How do I really reduce the consumption of my raw materials? How do I use waste to energy? how do I really go for low grade material to convert into something else? Can I replace my raw materials, which is causing more impact? So that is where this inventarization, and when I look for resource efficiency and waste reduction, I will be able to do it. Then third aspect is you go for impact assessment, look for circular economy and innovation, and then finally you need to look for what is the benefit the business is going to get, and is it actually helping my sustainability goals. Okay, simple. Have you understood? Shall I move? All of you should be with me here, otherwise people typically say that after lunch session will be difficult, and I'm lucky that I have a session before lunch, and I think half of you are sleeping. Prove me wrong. Okay, so that is where the engineer, when you design something, you have to go for trade-offs to look for how do I really go to convert this life cycle assessment to sustainability goals. Okay, here is a question for you. All of you seen this type of bottles? Imagine you are a sustainable engineer. You've been asked to do a life cycle assessment, and the boss says, for my milk manufacturing company, should I use plastic bottle or should I use PET bottle? Which one will be better? Let us go for a voting. I would have gone for a Mentimeter, but sorry, I didn't do it. How many say bottle? Raise your hands. No one? One, okay. Tetra Pak? So many, very good. Sir, how would you say? Very good. So, majority says Tetra Pak, right? Now think about it. Had it been so easy, why did I put it in the slide? कुछ तो गड़बड़ है ना? Now let us look at what is the thing. Same process steps. Okay. Now what is my goal? Business objective is 1 liter of juice or milk, whatever you want to do. And what are the goals? It should be leak proof. It should be sustainable. And it should be. These are my 3 goals. What is the scope? I have to look from raw material extraction to manufacturing, transportation, use, and end of life. End of life. Please remember this. Okay? Now, then as an engineer, what you are supposed to do? You are supposed to evaluate it, right? Assess impact. Inventories and assess impact. Okay. Now let us look at PET, PET plastic bottle. What is the raw material? Plastic, right? And you need energy for molding and labeling. And what is the weight of this plastic? 40 grams per bottle. And then I am looking at impact. Higher global warming potential. Okay? High energy consumption. Easier recycling. High energy consumption again. Okay? Now let us look at this option B. Paper plus polyethylene. Why do I need polyethylene? If I go for a plain carton, paper carton, there will be a possibility of not being leak proof. So I can build it, but tomorrow people will not buy it. So that is where I have to make it leak proof. So I have to go for polyethylene also. And I need lamination and printing. So I need energy for that, right? And weight is low. If the weight of the Tetra Pak is lower, the transportation cost will also be lower. Agreed or not? Now, lower global warming potential during production, difficult in recycling. Why? There are mixed materials, right? And lower transportation emissions due to lighter weight. Transportation emissions are lower. Agreed? Now you have to go for interpretation of result. The most important part and complicated part. What can you do? I'll go for design optimization. So how do I reduce this weight? I go for, can I reduce the PET thickness? Or use recycled PET? In case of this, can I go for mono material layers, which is easier recycling? Can I do it? if you remember, if you look at your water bottles, plastic water bottles, these days, you can think that the quality of paper, the plastic is very thin, right? Your mother typically used to keep those plastic bottles in house, right? घर पे सबका घर पे रहता है ना, whichever way से फेंक दो, फिर भी that will be there, right? Because they typically use it as reuse purpose, right? And she will be complaining, ये कुछ फायदा नहीं है, फट जाता है, right? Because it's very thin. And monomaterial layers, people are using this Tetra Pak with mono layers only, so that it is easier for recycling. And can I go for biodegradable plastics or plant-based polymer? So these are the you are actually evaluating different options. Can I use this? Can I use that and all that, right? Everywhere there is a trade-off. And finally, you go for decision making. Decision making is also not easy. If my place has got a recycling infrastructure, I'll go for PET, plastic bottle. If landfill avoidance is priority, you will go for carton with compostable lining. Could be better, right? Now let us look at something else. The life cycle cost for a PET bottle is $0.046. Okay, this is $0.095. So just from the sustainability point of view, if you go to the businessman and say that, Bhaiya, go for Tetra Pak. All of us voted for Tetra Pak, right? तो क्या करेगा आपको? He will fire you as a consulting engineer. You will lose your job, right? So, of course, this is illustrative. Please don't say that I have recommended this. Okay? And ISO sir, don't put it in your seminar saying that this is what is recommended. Okay? So the essence is there is no universally green option. All you have to do is evaluate between different options and find out the best way to take it forward. Agreed? All of us are aligned? Okay. Now what basically is this is a product life cycle. We have discussed this when you discussed the example of sabji making, right? You have got certain raw material which is being extracted, then you have got production, then you have got products which after the end of the product life, it goes for disposal, right? Now, when you look for life cycle assessment, it actually covers all these areas, okay? And what are the different things you have to look for? Raw material extraction, you look for resource depletion. What is the energy use? What is the emission? Can you go for recycled material? Recycled material can be anything. Recycled steel, recycled wood, plastic. Can I go for recycling of e-waste? So there are different opportunities which you can evaluate. Production. Can I reduce my energy use? The VVFD drive example which I have given is basically an example where I can reduce the energy use. Can I reduce emission? Then product. Can I make the product more durable so that it can be reused? Or can I make it more energy efficient? Can I make it more easy to maintain? These are the different options or thoughts you should be able to do to take it forward. Similarly, end of life. Is it possible for me to recycle it? Can I reuse it? Can I go for safe disposal? And so on. Right? So these principles, these are the basic principles which actually translate how projects are conceived and built and operated. So as a consulting engineer, my people are basically evaluating this and taking it forward. Right. So let us try to look at certain examples. I know the video presentation is not clear, but let me try to explain this. Anybody who has visited Singapore? No? You must go. कल सुबह जॉब करने के बाद, not in your papa's money, okay? This is Marina One in Singapore. It was certified as the best green building, green area. Okay? What they have is 37,000 cubic square meter of multi-layer garden called Green Heart, promoting biodiversity and urban greenery. And They have got green engineering features like rainwater harvesting, natural ventilation, sunsetting. All these things are new, is it? Rainwater harvesting, is it new to us? Can you tell me when people started using rainwater harvesting? क्लास 10 में आप लोग पढ़ा होगा. I am telling you because my son just cleared, he's in class 12 now. In places like Rajasthan, where the water availability is very low, people started using rainwatering there. Now it has become a buzzword. है ना? And if you look at natural ventilation, if you look from our age-old houses, buildings, caves, everything was actually built on natural ventilation only. And then we started using something called as AC, right? But can you use this? The idea of telling this is, when these people built it, they actually looked into this. And this is where they optimized biodiversity and energy performance at both taken together in the design stage itself. Because please remember, the moment you do something in the design stage means it is not built in. Once you build it, you cannot change it, or the cost of change will be difficult. So at the design stage, if you are being able to do it, most likely the cost you take to redo it will be less. So that is where the consulting engineers will have a very, very critical role to play. Now let us look at another example. Tesla Gigafactory. Can you see this? Entire solar panel. The idea is what? Energy and material efficiency. And they've got so many other things. They've got 70 megawatt of solar panels and highly efficient LED light, right? And so many features. They recover 92% raw material through a closed loop battery recycle system. So these are the design concept where they've actually built in during the design step, so that this entire manufacturing is basically a sustainable design, and they have been recognized for this. All of us use mobile phone. 5 साल के बाद क्या करते हैं आप लोग? How many people use, especially youngsters, after 5 years? 5 साल में मोबाइल चेंज नहीं हुआ तो क्या करते हो आप लोग? धरना नहीं देते हो घर पे? नहीं करते हो? The average life for a cell phone now in India is around 3 years, right? Unless you are using an iPhone. Okay, this is a Dutch company, Fairphone, and the concept is, the design is for extended product life and end of life recovery. Again a design concept, right? What they have done is, this modular design enables easy replacement of batteries, screens and cameras. I don't know how many of you started using Nokia phones, small phones. Youngsters may not be knowing, there used to be a Nokia phone earlier. And the battery was replaceable. Then what happened? Can you replace batteries now in the mobiles? Why not? What was the reason why they have not gone for that, replace the battery? Sorry, I cannot hear you. Why they have done it? Why Samsung or anybody has gone for that? Not actually the fact. The reason is, आप लोग देखे होंगे, those people who had used older Nokia phone, after certain use the battery used to bulge out, and then it used to catch fire. So it was a safety hazard. Phone फट जाएगा तो किसका जाता है ज़्यादा? The company. Samsung का phone फटा मतलब Samsung gets a bad name. तो क्या कर सकते हैं हम लोग? ऐसे करो कि 3 साल is the life of the battery. 3 साल के बाद काम ही ना हो. The person is going to buy a new cell phone. So safety hazard has been eliminated. My brand reputation has been maintained, right? But these people have done that. You can replace everything. The idea is to go for a sustainable design. Okay. Typically, many places industrial installations are in a remote location. Okay. If you go, suppose you are manufacturing, have you gone to this Jayashree Chemicals? Anybody? There is a caustic soda factory near Ganjam. The raw material is the brine, right? Raw material is the brine. Brine is nothing but sea water. Agreed? Now the sea water will be pumped somewhere else. How do I monitor that? Sea water comes from the middle of the sea, right? It's in a remote location. I cannot have a person there manning that place. So I will go for something called as Internet of Things, IoT sensors. How do I power them? So this is a remote harvesting IoT devices. Tata Chemicals in Gujarat use this remote sensing, IoT devices, energy harvesting IoT devices, which is self-sufficient. Because otherwise somebody has to go there and do it. So again, this is sustainable design. Okay. The idea of showing all these things is, what I am saying is nothing directly from textbook. It has been done by people, and I'm sure you people can do much better than this. This is from my subsidiary company called EcoFirst. They have created this Hindustan Unilever Research Center, Bangalore, which is actually best in class design, net zero energy. Okay. All right. All of you are tired now? Hungry? How much time I am left? Do let me know, otherwise. Sir, I am not eating your anybody's time, na? Okay. But don't blame me afterwards. Okay. All right. So now let us look at product life cycle. What happens when as a consulting engineer, what typically I do? The customer will come, say that this is the product I am going to make, and this is the capacity of the plant, right? So what I am supposed to do? Everything starts from a concept stage. Okay. Once I design the project objectives, I do the scoping, I do a risk assessment, I'll find out then feasibility study, whether it is feasible or not, which is my location, from where I'll get my raw material, from where I will get my energy, from where I'll get water and so on. That is where I go for feasibility. Then comes the design stage. Once I design it, I go for procurement. What is procurement? I need certain equipments, I need certain cement, I need steel, all these things has to be procured. And once it is procured, the next step is to go for, you build it and then commission it. And once you commission it, what happens? I hand it over to the person, right? And they operate. They not only operate, they also maintain it. This is very critical now. All of you own a bike or four-wheeler? Hanana. So when you, which one, four-wheeler or two-wheeler? Two-wheelers, okay. When you buy that two-wheeler, माइलेज अच्छा है, कलरफुल दिखता है, राइट? कौन सा, एक्टिवा और विच वन? Okay, whichever. So let's not fight over that. So what is normally happens after 1 year, 2 years, 3 years? गाड़ी रखते हो ना, बेच देते हो. क्या होता है? प्रॉब्लम चालू हो जाता है, माइलेज कम हो जाता है, this happens, that happens. Why? Because unless until you go for proper maintenance, any machine as a human being, at the age of maybe 21 years, when I was with Prasad sir, all of us were very young, right? And now slowly we are getting decayed, right? Similarly, machine also, when it operates after a certain period of time, it also starts to deteriorate. The performance comes down. Okay, and once the performance comes down, what I do? और कितना साल चलेगा? And then once that useful life is over, I'll have to decommission it, and then I have to look for the waste generated to be managed. So this is basically a project life cycle. Now let us try to find out what are the opportunities there for you to look for sustainability or from life cycle assessment point of view. Same steps. What I can do during concept stage to design stage, I can look for energy efficiency, I can go for a life cycle assessment, I can look for exploring renewable energy. Okay. Then in the design procurement stage, can I look for green procurement? Can I go for recycled material? Build and commission, can I reduce waste, construction waste? Then next is operate maintenance. Can I look for predictive maintenance instead of preventive maintenance? You understand what is preventive maintenance and predictive maintenance? when you purchase that vehicle, the vehicle owner, the vehicle manufacturer gives you a manual saying that after this many kilometers, go for a servicing, right? 1 साल तक करो, 2 साल तक करो, 3 साल तक करो. That is called as preventive maintenance. So उसमें क्या होता है? The difference between preventive and predictive is आपको oil change करना है after 1 year. Whether the oil is good or bad, he is not going to look into it. He is going to clean it. So that is actually waste also. Sometimes you are generating more waste. Instead of that, if you go for predictive maintenance, what happens is you look for the oil quality. If the oil quality has actually deteriorated, you look for replacement. That is what is predictive maintenance. And these days, with the advent of IoT, sensors and all that, automation, there is a focus of the entire industry is actually shifting towards predictive maintenance. I was in UK for almost 5 years, and I actually was the person who was driving asset integrity management. Asset integrity management, one part of that is predictive maintenance. Okay. Next is, in case of decommissioning, I have to be very responsible. How do I really reduce, dispose it? Can I go for material recovery and all that? So these are the different opportunities you have for using a life cycle assessment lens and sustainability to really build sustainable design into your entire design, build and operate phase. Sorry. Okay. This is the last slide, but little prescriptive in nature. What I have tried to do is, how does our people do it? So there are 4 segments here. So let us start with the first segment. If you remember the earlier slides, I had shown you 4 different steps. First was goal and roadmap. What are you supposed to do? Typically, what people do is you start with requirements. What is the requirement? What is the customer requirement? What is the regulatory requirement? Because it's not that only customer requirement suffice for a design engineer. You have to look for the government regulations. What is the regulations says? What is